Welcome back to the deep dive, everybody. Today we're going deep on how to make AI, smarter, like actually reason better. And we're focusing on this system called Scallop. Pretty interesting tech, really pushing the boundaries of software engineering and AI as we know it.
Yeah, definitely. Neural networks are amazing, right? Image recognition, natural language processing, all that. But when it comes to like abstract reasoning, they kind of fall short. So Scallop is trying to solve that, bringing together the strengths of those neural networks with the more structured, logical, symbolic AI side of things. Really, the idea is to like get rid of the weaknesses by, combining them, kind of like Voltron.
Right, exactly. So today we're going to break down Scallop, like what it is, how it actually works, the computer science behind it, and then like what it can do for making AI smarter across the board. We've got some cool new research we're diving into. Should paint a pretty clear picture. So first things first, what is Scallop, like fundamentally from a CS perspective?
Well, at its core, Scallop is a declarative programming language. And it's based on Datalog, which, for computer science folks out there, it's a logic-based query language. Really powerful for relational data. So that's like the foundation, these logical rules, a big part of what symbolic AI is all about.
Interesting. So not reinventing the wheel, but using like solid, established CS principles. So then what does Scallop like actually do? What's its main function as a software, tool?
It's a data log solver, a really scalable one. But the cool part, especially for AI these days, is that it can handle like different types of reasoning, discrete reasoning, probabilistic reasoning, even differentiable reasoning. Think of those as like different ways to get to an answer computationally, and Scallop can, switch between them depending on what the AI task needs.
So not a one-trick pony, lots of options there. Now, when it comes to actually using Scallop, how does it fit into the software ecosystem? Does it play nice with other tools and libraries, or is it more standalone?
Integration is really key to how it was designed. Scallop has these things called bindings, right? And basically what they do is let it act like a logic reasoning module right inside your Python code. For software engineers, machine learning folks, that's huge. It means you can integrate it directly into your existing ML workflows, especially if you're using PyTorch, which, let's face it, tons of people are.
Yeah, that tight integration with PyTorch could really change the game building those more, advanced AI systems. So let's zoom out for a second, talk about this whole neural and symbolic AI thing. For someone who might know, like, one way better than the other, what's the main idea behind this neuro-symbolic approach, and where does Scallop fit in, like, architecturally?
Sure. So neuro-symbolic AI. It's basically trying to take the best of both worlds, right? Two areas of computer science that have kind of separate for a while. Neural networks, they're the champs at pattern recognition, learning all those complex relationships straight from the data. But symbolic AI, on the other hand, is all about representing knowledge in a structured, logical way, doing that rule-based reasoning. So think of it like this. Neural networks can learn to recognize a cat in a picture, but symbolic AI can define what a cat is, how it relates to other animals, that kind of thing. Yeah, okay, that's a good way to put it. So each has its own, like, superpowers and kryptonite, right, when it comes to tough AI problems. Exactly. And the argument, big names like Leslie Valiant, Gary Marcus, they've been saying, for AI to get to, like, human-level intelligence, really reason, understand cause and effect, generalize beyond just the data it's trained on, we got to bridge this gap. Symbolic AI gives you that framework for abstract knowledge, logical manipulations, neural networks. They struggle with that.
Makes sense. So how does Scallop, as a piece of software, actually enable this combination? How does it all work?
It's the symbolic reasoning engine, basically. It can talk to those neural components. Developers can, write out these logical rules and then connect them to the output or even the internal workings of neural networks. And to make things even smoother, researchers built more specialized frameworks on top of Scallop to make that integration super sleek. One of the best examples is Viara.
Viara, okay. Tell me more. How does it build on Scallop?
So Viara, it takes Scallop and adds this probabilistic relational approach. It's really designed for those big foundation models we hear about all the time. The cool part, from a CS perspective, is how it treats those models, like GPT for language, CLIP for image text, SAM for image segmentation. It treats them like stateless functions, basically. They take in structured relational data and spit out, more structured relational data.
So instead of just throwing raw text or images at these huge models, VR lets you interact with them in this more structured way using Scallop's relational logic.
Bingo. And because Viara is built right on Scallop, it's super natural to combine these cutting-edge foundation models with good old-fashioned logic programs. Huge potential there. way more sophisticated AI applications, reasoning across all sorts of data types.
That's a game changer for sure. So let's get into the nitty-gritty. How does Scallop and Viara by extension actually talk to these foundation models? From a software engineering point of view, what's going on under the hood?
One of the core things is this relational programming, right? It can actually call out to the foundation models. There are two main tools for that: foreign predicates and foreign attributes.
Foreign predicates, foreign attributes. Okay, break it down for me. What are foreign predicates exactly?
Okay, so think of them like special functions you can use within Scallop's logic rules. Regular predicates work on data that's already in Scallop's knowledge base, right? But foreign predicates, they can reach outside, call these external functions, like talk to a language model's API. The key is they take some arguments that Scallop already knows. Those are the bounded arguments. And then based on what that external function says, they return new info, the free arguments. And to make things run faster, there's this memoization thing built in. It's a classic CS trick, basically stores the results of those expensive function calls, so if it sees the same inputs again, boom, it reuses them, saves a ton of time.
Love me some optimization. That memoization is super practical, especially for real-world stuff. What about those foreign attributes then? How do they work?
So foreign attributes are basically like higher-order functions. You use them to decorate the predicates you declare, like adding a little note. This lets you configure things, abstract away some of the messy details of talking to those external models. Like Viara, it has this add GPT attribute. You slap that on a predicate, you're basically telling Scallop, hey, this guy's going to be using GPT for text generation or completion. The arguments you give to add GPT can specify things like the prompt template you want, or even some example inputs and outputs to guide the model, kind of like few-shot learning in ML.
Ah, so the add GPT attribute is like a nice little wrapper, makes it easier for software engineers to use GPT within their Scallop kind, hides all that API call stuff and data formatting, right?
Exactly. Raises the level of abstraction. Much easier to work with these powerful models when you're writing logic-based programs. Now, let's see some real-world examples how Scallops, especially with Viara, actually uses these different foundation models. Let's start with the language models, all those text-based tasks.
Yeah, we saw that a GPT attribute before. How would that actually be used, like in a real program?
Okay, so you could use it to make a predicate that pulls out specific information from some text. Say you define a rule like population, location, dot population, and you decorate that population predicate with @GPT, right? Give it a prompt template that's like, what is the population of location? Now, whenever your Scallop program needs to find the population of, I don't know, London, it'll use GPT to try and answer that based on the prompt. You can also just use basic foreign predicates to have GPT do more open-ended text generation based on whatever logic your Scallop program is working with.
Okay, that's really cool. A structured way to get info from all that messy text data. What about tasks where you got to understand the meaning of the text, like semantic parsing?
Viara has you covered there. It's got attributes like edg semantic parse specifically for that. You basically define domain-specific language, or DSL, which is like a formal, structured way to represent the meaning of natural language within a specific context. Then you use that edg semantic parse attribute to have a language model translate regular language queries into your fancy DSL expressions.
So someone could ask a question in plain English, and the system uses GPT to turn that into a precise machine-readable query, something your program can actually work with. Nice bridge between how humans talk and how computers think. What other text stuff can Scallop handle?
It's also really good at pulling out relational data from text. You've got the @GPTextract relation attribute, lets you tell language models to find and extract facts, usually in the form of those subject, predicate, object triples, straight from unstructured text. Often what's happening is you're prompting the model to give you its findings in a structured format, like JSON, easy for Scallop to parse and add to its relational knowledge base. So for example, given a sentence like, Alice works at Bob's Bakery, it could pull out the triple, Alice works at Bob's Bakery.
Huge for automatically building and populating knowledge graphs, especially when you've got mountains of text data to deal with. Okay, let's switch gears to visual data. How does Scallop play with those image-based foundation models?
Lots of cool ways. For basic stuff like image classification, you can use attributes like @clip, which brings in models like CLIP, train on tons of image text pairs. They get the semantic connection between the two. You just give it a bunch of text labels like cat, dog, whatever, and then apply the @clip attribute to a predicate that takes an image as input. Scallop uses CLIP to figure out the chances of that image belonging to each label, usually giving you a probability score for each.
So you can do image classification just by describing the categories you want in words. No need to train a separate image classifier. Very flexible, like zero-shot learning in action. What about more complex stuff, like finding specific objects in an image, knowing where they are, all that?
Viara uses some state-of-the-art models for that, like OVL, VIT, and the segment anything model, SAM. You can use attributes like at Owlvit with a list of object categories you want to detect, say car, tree, whatever. When you apply that to an image, the model picks out regions, segments within the image that match those labels. It can even extract info like the bounding box coordinates for each object it finds. And SAM, on the other hand, can segment any object in an image if you give it a prompt, like clicking on the object. That's how Scallop programs figure out what's in the image and where everything is.
Not just recognizing what's there, but pinpointing it, outlining it, really getting close to that richer visual understanding we want in AI. What about the flip side, generating images from text descriptions?
Yep, VR does that too. Attributes like at Stable Diffusion, they bring in those powerful diffusion models. You define a predicate, takes text as input, spits out an image. You can even tweak parameters, like how detailed you want the image, how many refinement steps it should go through.
So from understanding images to creating them, all based on language, Scallop with Viara seems like a pretty complete toolkit for working with all these different foundation models, no matter the data type.
Absolutely. And to really show what it could do, the folks who built Viara, they tested on a whole bunch of tough benchmark problems, covered a bunch of different AI
Oh,
areas.
that's cool. What kinds of tasks did they try out?
Tons of stuff. Really impressive. Natural language reasoning, they looked at tasks that need logical thinking, things like reasoning about dates, keeping track of objects that are shuffled around, understanding family relationships, even solving math word problems. For a lot of those, they used GPT-4 to grab the important info from the text first, and then Scallop's logic engine took over, did the actual reasoning based on what GPT-4 pulled out.
How did the Scallop-based approach do compared to other methods on these reasoning tasks?
Really well overall. For example, for that object tracking task, they got perfect accuracy. Shows how powerful it is to combine language understanding with precise logical tracking. For the family relationship stuff, it even beat some methods that just relied on super fancy prompting techniques for large language models. Really highlights why having that dedicated reasoning component is so important.
Yeah, that's a great example of the neuro-symbolic approach working its magic. What about tasks that involve, like, finding and using information from different sources?
They tackled question answering with the Hotpot QA dataset, which needs information retrieval. They took this existing technique, FE2H, and adapted it. Basically, they used embeddings to find relevant documents first, then used a language model, guided by Scallop, to answer the question based on what they found. They also explored product search using the Amazon ESCI dataset, looking at how to break down search queries to really capture what the user wants, including things they don't want, like not blue.
And on the computer vision side, what applications did they look at?
They tackled compositional visual question answering, using datasets like GQA and CLVR. These are tasks where you need to understand how different objects in an image are related to answer questions. They usually defined a DSL to represent the visual queries and used models like VLT and OWLVIT to get the visual info. Then Scallop's logic took over to figure things out. They also worked on visual object tagging, combining knowledge bases with object detection and visual question answering models to automatically tag objects and images with relevant concepts. And finally, they explored language-guided image generation and editing, using a mix of language models like GPT-4, diffusion models, and DSLs to manipulate images based on instructions written in natural language.
Wow, they really put this framework through its paces, tackling some tough AI problems across the board. What were some of the big takeaways, general observations from all those experiments?
One of the biggest was just how programmable the Scallop-based Viara framework is. They found that the code for solving these really complex tasks was often surprisingly short and sweet. Shows that the framework is a really powerful and efficient way to write complex AI logic. Plus, they noticed that even people who weren't experts in logic programming could use the framework to build pretty sophisticated solutions.
Yeah, that ease of use is crucial if you want any new tech to really take off in computer science and software engineering.
For sure. Another big plus they pointed out was how interpretable and debuggable this neuro-symbolic approach is. Because Scallop works with clearly defined logical relations, you can actually see the steps of the reasoning process. Makes it way easier to figure out how the system got to a certain conclusion and to find and fix any bugs in the logic or the way it's talking to the neural components.
So it's not just about getting the right answer, it's about understanding how the AI got there. Huge for building trust and understanding these systems.
Exactly. So, to sum it all up, what are the key takeaways from our deep dive into Scallop and frameworks like Viara, thinking from a CS perspective?
Well, it seems like Scallop is a really strong contender in the world of neuro-symbolic AI. It provides this solid, well-grounded way to tightly connect logic-based reasoning with all sorts of machine learning models, including those big foundation models that are getting more and more popular.
Could have said it better myself. And this integration has a lot of benefits when it comes to building better AI systems. Makes them way better at reasoning, give them a way to ground their knowledge and avoid making things up, handle structured data more effectively, and lets them tackle those complex multimodal tasks where they need to understand and process different types of information all at once.
Looking forward, what's on the horizon for research and development in this whole neuro-symbolic programming thing with Scallop?
One exciting avenue is going beyond just in-context learning, where the model learns from examples in the prompt. Researchers are looking at how to bring in more traditional ML techniques, like weekly supervised training, and even fine-tuning those foundation models themselves, all within this neurosymbolic framework. Could lead to even more adaptable and powerful AI systems, ones that can actually learn and get better over time, in a way that's still grounded in logic.
So to wrap it up, it sounds like Scallop is a big step forward in our quest to create smarter, more reliable AI, really pushing the boundaries in computer science. By smartly combining the strengths of neural networks and symbolic reasoning, it opens up a lot of possibilities for solving some of the toughest problems in AI.
Absolutely. That teamwork between data-driven pattern recognition from neural networks and the structured, logical thinking of symbolic systems, that's what Scallop is all about. It really feels like a key turning point in how intelligent systems are evolving.
And with that, we'll leave you with a question to ponder. As AI keeps advancing at this crazy pace, how might this deep, principled integration of neural and symbolic approaches, like what we've seen with Scallop, change the face of intelligent systems and software engineering as a whole? What brand new computational problems could they be the perfect tool for? What does it all mean for the future of computer science and beyond? It's a fascinating area to keep an eye on, that's for sure. Thanks for joining us for this deep dive into Scallop.